Alright guys, this is this week in your 4-8 homework. It was originally due on the 1st. That was a mistake. I intended it to be the 7th always, and it was pointed out to me that the notes didn't jive with it. There was nothing on in the Moodle notes on 4-8 material antiderivatives, and that was because it wasn't supposed to be this week. It was supposed to be the 7th. I guess maybe my 1 looked like my 7 when I was doing my calendar. Anyway, that was a mistake, so it's been moved to the correct date, and I appreciate you guys for notifying me about that. So that's the first thing. But the big thing is this project that I want to kind of talk with you about to make sure that you're understanding it. I am going to upload it in the format of a Word doc, so you can edit it as it mentions to do in there. So just know that I will put that on there that way. Let's go through it and just quickly talk about what's going on here. So Newton's method, what is it? It's a way that we use the derivative at a point to guide us to a new, better guess for a root being an x-intercept. That's just another name for a root, a zero, a place where the graph crosses the x-axis. All right, and it has to be what we call a real root. I don't know if you remember that from pre-calculus, but a real root just means it's on the x-intercept, an actual x-intercept that we can see if we graphed it. And that's what we're doing here. We are trying to find the real roots, the x-intercepts with Newton's method. Okay, so the first part that you're having to do is come up with what Newton's method, what it is, deriving the formula. So the thing I've told students in the past, what you have to do here is literally you have to start out with this. You have to start off with the slope formula and go up into this this up here and find what belongs in the formula. So here's your 2 points that I mentioned in there. There's 2 points here. There's this one and there's this one. Okay. And what are the coordinates of those 2 points? So this one's pretty easy. It's xn, fxn. So that's a point pair. And yes, that would mean this is xn plus 1, f of xn plus 1. But this is the root, the new guess is the root of the tangent line. So since it's the root, there's a specific number that you can replace f of xn plus 1 with. So that means I'm going to replace this stuff. I'm going to say, instead of y2 and y1, I'm going to say f of xn plus 1 minus f of xn, alright, over xn plus 1 minus xn. Alright, I'm just plugging into the formula. Okay, I'm just replacing these things with what they are. Now this is a special value that you came up with that I just mentioned. So you're not going to use that notation. You're going to use whatever you get for that value. I'm not going to tell you what it is. It's part of what you're supposed to be doing here. Okay, now again, I'm just replacing everything in here with something from that picture over here to the side. So I'm replacing it with these things, this things, and then I have to come up with, well, what is m equal to here? What am I going to replace m with? And that's also part of it. You have to understand m has a value in that last page that needs to be replaced in as well. Okay, so you're just plugging into the slope formula. Slope is so important in a calculus course. Hopefully you're starting to see that there is a slope everywhere, like where everything that we do has something to do with slope, basically. Alright, and then the second part is having you to visualize it. So what you're doing here is you are going to get a straight edge if you need to, and you're going to go straight up from x naught. You're going to hit the graph. That's f of x naught. Alright, so you hit it there, and then you make a tangent line. Okay, Newton's method says once we have our tangent line at a point, at our initial guess, we make a tangent line, and we get a better guess. So if I can get that curve back, nope. And when I get this better guess on here, it's going to point to the next best guess. So let's pretend I made that go all the way down to here. And that would be my x sub 1. Okay? And then I hit it again, make another tangent line, and this is not exactly tangent the way I've got it drawn here. I would have to do a little bit better a job at making it tangent. So yeah, all this stuff would need to then move. Alright, so there would be my next guess. So again, make sure it's tangent, make sure it's just barely touching. And you need to do 2 iterations of that, so you're going to have to do it again and make sure that you draw the tangent line that goes along with this second point. So you have to do another tangent line and repeat the process. Just do x1 and x2. Okay, so make sure that you're understanding what's going on with the visualization of Newton's method. Alright, and then finally doing it. So here's where the most you're going to need this tutorial. If you've never used Excel, if you're not familiar with Excel, you're going to need to go through this and understand this. So copy this. Again, once I have the word went on there, you can just copy it. Have Excel open, and you're going to open it, paste. Control V is paste, Control C copy if you're familiar with those keyboard shortcuts. And then I would go here and make sure these guys are the widths are the same. You can just double click to make sure that you can see all the words that are in there. Alright, now guess. It says your first guess, you should type the natural log of the natural log of your birthday. So the natural log, let's say, I'm going to use this example that's in here. Natural log, notice that it comes up with a formula that it has built in. So it understands natural log is what it's basically telling you. So the natural log of the natural log, do it twice. That wasn't an error, it wasn't a misprint. It needs to be in there twice. Natural log of the natural log of your birthday. So if your birthday was April 19th of 1997, then you would type in 4/1997. Okay, and then you close both of those parentheses. So there's your initial guess. So 2.365. Okay, if your birthday was October the 7th of 2001, alright, there's your initial guess. Okay, so you just type in the natural log of your birthday. Okay, it's going to be some number between 2 and 3. Alright, now here's the big thing. Here's where you have to understand how to tell Excel things. This function that we're dealing with is e to the negative x minus natural log of x. In Excel, I have to type e equals if I'm going to do any type of math in a cell. And then when e shows up, this e to the negative x, I need to use Excel's exponential function. So that's exp. Alright, notice exp, it tells you that returns e raised to a power. So exp, open parentheses. Now notice it's negative x. Negative x. So I'm going to put in a negative sign. And then when it's time for an x, notice the name of this guess column is x. These are the x's. So I'm going to click the number in the cell. So I get exp negative and then a cell number. And that's what I need. I need it to do that. Alright, so there's e to the negative x minus the natural log of x. So minus ln again, returns the natural log of a number, ln of x. Anytime I get to x, I need to click my guess. So there's what it should look like in your first cell. Alright, and then the derivative. Okay, now you need to be able to take this derivative. That's part of the project. There's my function. The derivative of this thing is what you're going to have to do to be able to do that next part. Okay, so I know this isn't right. Alright, I'm just going to say, what if it's negative 2e to the negative x minus 5 over x squared. Okay, that's not right. I'm admitting that's not the true derivative, but I'm just giving you something that if this were the derivative, how I would put it into Excel. Okay, you have to get it correct. You have to get the correct derivative and do this into Excel. But I'm just showing you if this were the derivative, this is how I would proceed. Alright, so negative 2e to the negative x. So in this cell, I would type in equals, I'm saying it's negative 2 times e again, so at exp. Alright, negative x, again, here's my x. Alright, minus 5 divided by x squared. So again, x, anytime I get to an x, I click the cell, squared. Okay, and then I would hit enter. Okay, that's not right, but you have to do it correct. Okay, so I'm not going to say that again. I'm just making sure, you've got to get it correct for that to be the right number, but that's how you would type it in. Once you get your derivative, you do the same thing you did for your f of x. You click the guess column, the guess cell, anytime that x shows up. Alright, different from previous guess. Well, right here, there is no previous guess. This is the initial guess, so I'm going to leave that blank. I don't have to worry about this tolerance over here. That's just identifying it for me. Alright, now my updated guess. For my updated guess, you need your answer to this part. So whatever you get here, when you solve this thing for xn plus 1, when you have that solved, that is Newton's method. So you'll have stuff, and it'll have stuff to do with f of x sub n, it'll have stuff to do with f of prime x sub n, it'll have some other stuff in there that you'll have to do, something to do with the x sub n itself. Alright, so there'll be some stuff over here with these three. Now again, I'm going to make up something so I can show you how to proceed. It's not right, but it'll show you how to proceed. So let's say that my formula was xn plus 1 equaled xn plus f xn over f prime xn. Alright, let's just say that's what I have to do to get it. So what this is saying is my old guess, to get my new guess, I take my old guess and I add this stuff to it. Okay, so what does that mean? Well, here's my new guess. All right, it's the next one in the column. It equals my old guess, so I click the old guess, plus the old function evaluated at this thing, so that was this guy right here, divided by the old derivative evaluated at that thing. Okay, now again, this is not right, but that's what it would do if I plop that in there. Okay, now from here you just highlight. Notice what I'm doing here. I'm highlighting those two cells, the f of x, f prime x, and I am dragging down. Alright, and what did it do? Notice it plugged in A3, the new guess, into there. It plugged in A3, the new guess, into there. And from now, here on, I'm going to drag down. And what am I looking for? Oh, sorry. The difference from the previous guess. The difference from the previous guess can now be done. What you want to do here is absolute value. So ABS for absolute value. And then your new guess minus your old guess. Okay, so since we have a new guess, we have a way to do a difference now. Alright, and now, from here on, you just highlight, you just highlight, and you can drag this corner down. Now notice when I go from a white cursor to a black cursor, when I hit that green square, that means when you go to the black cursor, that means you can autofill. So I want to autofill down. And my goal, if I've done it right, and I haven't, which I said, if I've done this correctly, this difference from previous guess should make its way towards 0. So if I do it correct, I should get this thing down further and further and further. Okay. Now I'm not going to type in the cells so you can see it, but I'm going to show you what a sheet would look like if I did it correctly. Alright, so here's the function y equals x squared minus 5. That has a 0 around 2.236. So if let's say my original guess was 4. And let's say my function is equals x squared. So I'm going to click x squared minus 5. And what's the derivative of x squared? Well, the derivative of x squared is 2 times x. Oops, I gotta hit equals, sorry. Equals 2 times x. Alright. How do I get my new guess? That's Newton's method. So again, you would have to know how to get your new guess. Alright, so I actually use the correct Newton's method to get my new updated value. Then I'm going to highlight these two, drag them down. Okay. I do have a difference between the previous guess now, so I can hit equals absolute value of this guy minus this guy. Okay, and now once again I can highlight the entire row and just start dragging down, and watch what happens when you've done it correctly. Eventually you'll get zeros. Okay, and this number is smaller than this number. You're actually comparing, that's why the tolerance is there. And as soon as we achieve the level of tolerance we want, we're done. That's all we need to do there in that case. So I'm going to highlight that row to say that's where it happened. So there's that 2.236 number. And notice beyond that, we're not getting any closer and closer and closer. So if you look at the graph on Desmos, what's happened is I started at 4. Alright, it hit the graph right here, and it sent me down to the next guess. What was the next guess? It was 2.625. So 2.625, 2.625, and I'll make that dashed. Alright, and it hit it again. It got a new tangent line. The new tangent line came down and it gave me a new updated value of 2.648. So 2.648 kind of shifted to the right. Oh, sorry, 2.265. I misread. It didn't make any sense that it would shift to the right. 2.265. So it's getting, it's basically right on top of it right now. If I zoom in enough, you can always make them spread apart. If you zoom in enough, 2.236, it quickly got down there really quickly. So 2.236, and again, now it's basically right on top of the actual root. Okay, so it is an iterative process, meaning it just keeps updating with a better guess, better guess, better guess. So that is Newton's method, and that's what you need to do. The big thing that you are after is, how do I get this new updated cell? And that's Newton's method. That's what you're going to answer right here. This formula will be what you use to type in into this third cell up here to be able to get it to update. And this is what it should look like when it's worked. Right, when it works, it shouldn't take many cells to do it. It should only be, your first 10 or 15. You should already have zeros that show up, because it's a very quick process to get these things very accurate.